Well, we just have some diagram or figure for allow you to think about how it works and or feel the external part of the system. And actually, we have A and B to have snapshots. Okay, snapshots of the system. And previously, we have t equal to 0. And the first arrival, the time instant is 0.4. So of course, we can check the 2. Check the 2, and then here we have time 0 times 0.4. And 0 then system stats. We have a number of server, maybe not number of server. Server status, number in queue, number times of arrivals, and time of that event. Here we just follow this one. Server status, number in queue, times of arrival, time of last event. Last event says the previous event. Well, 0, so of course, 0 means idle. 0 currently no customer in queue, and currently it's empty. All right, so this is array, therefore empty. Set it to empty. And the next one, this is the first event, so of course the previous event is 0. All right, and the current clock is 0. Is it okay? And the arrival and departure is just the upcoming arrival and upcoming departure. So upcoming arrival, sure, upcoming arrival. And upcoming departure, no. No, we use infinity. At this moment, I don't know, so it's infinity. Well, I use a way system state. How to determine system state? Let me know. So I go through this first, and then I check clock. I check upcoming arrival, upcoming departure, right? And of course, because right now we don't have any accumulated area. So accumulated area 0, accumulated area 0. And delay, remember? We need to know delay for first customer. Right now, no first customer, so of course start from 0. Here, this is sample size. Number delay. Why we use number delay? Because this time we care about how to have the sample size for delay. So of course, number delay, it says we collect delay for first customer, second customer, and the other customer. So here, number delay means we can know the delay for that customer. Right now, initially, we don't have anyone, so of course we set it to 0. But here, maybe you have a question. Why number delay equal to sample size? Because we find it, so delay. Or maybe you have the problem. Number of customer with the captured delay. Well, if you want to have the exact meaning, I can use this way to let you have the meaning for number delay. If you don't care about that one, I just let you know number delay is equal to sample size exactly. Currently, sample size is 0 because we don't have any sample regarding the delay, queuing delay. Well, about this, it's okay. If you understand this, And if you don't think everything's depart, yeah, 0 for most of them. Only for upcoming arrival and upcoming departure. We have the next one. So next one, if we check the source code, then you can understand how to invoke the arrival to get 0.4. And also, D, if we don't have any next departures, of course, it's set to infinity directly. Well, that's it. So only this one, you need to invoke a suitable routine to get the value. But this time, we have the given value. So we gotta have the given value. And don't care about how to invoke a subroutine to get the value. Well, this is time isn't 0. It's okay? If its time isn't 0, that's fine. And then jump to the next one. Time isn't 0.4 because right now we can jump 0, then no processing. It doesn't mean no processing. 0, we have initialization. So 0 doesn't mean we don't have any processing. So after initialization, then we can jump to 0.4 because of neta. Well, up now, maybe you have a question. Why this one can use neta? Because of the system is single server queuing system. And actually, you can check further. It seems to be this one suitable to apply neta, but you don't have the rigorous reason. At least I don't know. Yes, it's okay. So I just ask you to follow. Yes, neta, so of course we can jump to 0.4 and check the update for the variables, update for all of these. Sure, if we follow neta and jump to 0.4, so of course we can check 0.4, right? And check 0.4, so here we have a clock 0.4, no problem. And a upcoming arrival. Previously, I have the calculation. So upcoming arrival. So it's 0.4 plus inter-arrival time. So this one, okay. And also, so this is AT2. And this is DT1. Right? Look at this. AT2 and DT1. I should change the color. All right, so up to now, this one, and this one, and this one. Well, if you understand these, check these. Server status, of course, busy. So it's 1. And currently, you just see the current customer and know the other, so of course 0. Right? And times of arrival, this one in queue. But right now, no queue, so it's empty. Right? And time that's event, once finished. This one, we need to check the code. So once finished, and then you have a time of that event. And this one right now, maybe hard to explain why we move to 0.4. But you can code once finished and this one serving as the time that event. And this one, we should check the codes and so that we understand why we have the value. But right now, time delay. Why time delay? Because this one queuing delay it's 0 because the first one jumped to the server directly. So we have the queue. Here we have Q1 equal to 0. So that's why this one known. Known, so of course sample size increase. Also currently total delay 0 here. So of course it's 0 again. It doesn't mean we don't have any accumulation. The current accumulation is 0. 0 plus 0. So we have a total delay is 0 again. So we have this. Well, maybe so far for some problems, so I leave it. Perhaps let me continue, and even you don't have the present live. So this one actually is Q1 plus 0. For some reason, I click on the wrong button, so that erase all. So this one, Q1 is 0. 0 plus 0. All right, so previously this one known and known and known. And this one I think we should check. And this one no, so of course we have it. And no Q of t, so 0. And no, actually 0 to 0.4, the area here is 0 for B and for Q. So of course 0 and 0. All right, that's it. So up now for the two time instant, we have initialization at 0, and we have the first time instant of arrival 0.4. So up now this one. So time of that event up now seems to be hard to tell, but later we can check codes and so you can understand why we have this value. But normally the current value seems to be after finish all, and then we will use this one to serve as line of that event for the next time instant. Therefore, 0.4 directly, normally no, it should be 0, and then after initial, then we will have 0.4 to serve as the time of the last event for the next procedure.